In this example problem, we have a box of mass 25 kilograms sitting on a surface that's inclined by 10 degrees. If the coefficient of static friction is 0.5 between the box and the surface, how much force must be applied parallel to the incline to just start the box moving down the incline? Alright, so this is an inclined plane problem because we're given an angle of inclination. So we can draw in our incline. So this is 10 degrees here. And we have a box sitting on top. Alright, so we want to know how much force must be applied to that box. So that means when we start our steps, we're going to sum forces on the box. So now let's identify what forces are acting on the box. Alright, so we have a mass here of 25 kilograms, so that tells us that there is a weight. So we're going to have a force due to gravity down like this. And because we have the rotated system, we're going to have negative x positive, or negative y positive x. Alright, and it is sitting on a surface, so that tells us that there's a force normal, and because we're in the rotated coordinate system, that force normal is going to be in the positive y direction. Let's see, what else do we have? We have a coefficient of static friction. So that is going to oppose the motion because we're trying to get it to start moving down the ramp. So force due to friction static is going to be in the negative x direction. And we want to know what the force applied is. This means that there is a force applied to push it down the ramp. Alright, so step 3 is to draw our free body diagram. So force normal is going to be in the positive y. Force applied is going to be in the positive x. The force due to gravity is in the fourth quadrant. And then force of friction is going to be in the negative x direction. Alright, so step 4 is to write Newton's second law. We're going to start with the x direction. So that's a force applied minus the force of friction static, and then we are going to have a force of gravity in the y, force of gravity in the x. So we need to, in this case, add the force of gravity in the x because it's in the same direction in the x direction as the force applied. Then for the y, we'll have force normal and then the y component of the force due to gravity, and that one is negative because it is pointed down. Alright, so our goal here is to find this force applied. In order to find that force applied, we need the force due to friction. And in order to find the force due to friction, and since we're trying to find the minimum force to get it to start in motion, we're going to use the maximum static friction. We need the coefficient of static friction times force normal. So we have to start by finding the force normal. Alright, so this is 0. So we have force normal minus mg cosine of theta equals 0. So force normal minus, let's see, 25 kilograms times 9.8 meters per second squared times the cosine of 10 degrees equals 0. That means that force normal is equal to 241 newtons. I can then plug that up here. So the coefficient is 0.5 given in the problem, times 241 newtons. So the force due to friction static is equal to 121 newtons. So we know force applied minus force of friction static plus mg times the sine of theta is going to equal, well, it's going to equal 0 because we're not moving in the x direction. We're trying to start it in motion, but we haven't moved yet. Alright, so force applied minus the 121 newtons plus 25 kilograms times 9 meters per second squared times the sine of 10 degrees sums the 0. That leaves our force applied to be 78 newtons.